Welcome. We're going to talk about a very Dutch subject, which is not originally Dutch anyway. But if you live in the Netherlands, you'll be confronted with the potato at least 5 times a week, traditionally. We're going to talk about potatoes. There's a big revolution going on in the world of the potato. Things are changing rapidly. And you might not always notice this, but this is, I think, a very, very important thing that is changing. Dirk Stemerding is from the Rathenau Institute. He's working on the project to see what can be done to, with all the changes in the potato market. And here's also Mr. Lindhout, and he's working for one of the big companies called Solynta that are actually improving the potato at this moment and have made an innovation. But we'll start about that later. Mr. Stemerding, can you explain to me what is happening in the world of the potato at this moment?
Well, perhaps it's a good idea that I explain a bit this notion of hybrid breeding. Breeding is the practice of improving crops and adapting them to our own needs. There are various ways in which you can do that, but one way which is very important in breeding is so-called hybrid breeding. And you could say hybrid breeding is a procedure which allows you more control over the breeding process. And the way it's done is that particular plant lines are created that are in a genetic sense have a very limited variation and are selected for particular interesting traits. And if you have then a lot of those different plant lines, you can cross them in ways that you bring particular traits together in ways you would like to have as a breeder. So at the moment that you have many of those plant lines, and you create these plant lines by inbreeding. So, that's the way you make these lines. You reduce the genetic variation in these lines, and you can select for particular traits, and then you can cross them, and that allows you to make a lot of different crosses and bring together different traits in different ways. So that's basically what we are talking about, hybrid breeding. The point is that with the potato, hybrid breeding up to now was not possible. And that has to do with the fact that the potato is in a genetic sense, a very complicated crop. And inbreeding doesn't work with the potato. So you have not the possibility to make these plant lines that allows you this control. And you can make crossings, of course, but it's much more difficult to predict what will be the result of these crossings, and you need a lot of time to come to a particular result.
Just to make clear, this has nothing to do with genetic modification.
This I learned from Pim, and he is now very happy with my explanation. So.
Which is a good thing. But we're not talking about genetic modification, but the difference between genetic modification and traditional breeding is not as big as is sometimes thought. People think, well, genetic modification, I don't want it, but breeding, you make use of all the knowledge from the genetics. You know exactly which habit, which trait corresponds with which gene. You use that, but the breeding is still traditional breeding. Is that correct?
Is this correct?
Yes, that's correct in the sense that to come back. Okay, thank you, Pim. I like this to do the explanation because it's a very good way to. No. Okay, to become more familiar to the subject, I think that coming back to this notion of control, hybrid breeding is a particular way to get more control over the breeding process, and there are other means to do that. And one of the other means is, for example, genetic modification. And you're right that means is not used. The way that Solynta, the firm where Pim is working 4 is not really the term, but it will indeed use this hybrid breeding as a means of control of the breeding process, but it will not use genetic modification as a means of control, although you could do that as well.
But you do use, you know exactly where the habit lies within the potato.
So you could say that's again another way you can get more control, and that is that there are now means to describe in a very detailed way the genetic the genetic components of a plant. And at the moment that you really know the detailed genetics of a plant, and you are also able to identify particular traits on the DNA level, on the genetic level, that again allows you more control over the breeding process. And still, we are not talking then about genetic modification, but you use these knowledge as markers, for example, to follow what you're doing when you are making crossings, and see whether particular traits indeed are included in the product you would like to create.
Pim.
Now to get a bit complicated. Now, one of the things is that with GMOs, also if you look at other crops, maybe at this moment there are 10, 15 genes which are used by GMOs. So the number of genes is very limited indeed. It's mainly herbicide resistant, insect resistant, things like that. If you look at the number of genes in a plant, in general it's about 30,000. So yes, you can add 10 to 15 genes to a plant by GMO, but the other 30,000 you have to breed just in a traditional way. Even Monsanto, known as the number one company in GMOs, they spend more emphasis on traditional breeding than on GMOs. Because if you put a new gene into a lousy cultivar, it doesn't work. So you have to do both.
Okay, but now let's talk about the traits, because that's what it's all about. You have the potato, you want it to be better. For instance, one of the things you do not want is for the potato to have diseases, or to be able easily to get diseases. Is that one of the things you were looking for in the innovation in the potato to make it more resistant against the potato disease?
Yes. To give an example, probably most of you know about Phytophthora. That's the most deleterious disease in potato. 50% of all the chemical crop protection agents in the Netherlands is just used for Phytophthora into potato. One disease in one crop. This disease is already apparent for 150 years. I mean, during the Irish famine, that was the main reason why there was so much hunger. And there are also 25 different resistant genes available. So basically, you can use these genes, introduce it in a crop, and then make a better variety. However, if you do it in the traditional way, so like today, it takes you about 15 years to introduce one gene into a cultivar. The adaptation of the pathogen takes 1 year. So you spend 15 years, you create a new cultivar, and 1 year later, the added value is gone. So you have to introduce 2, 3, 4 different genes, and then that's more durable. That has stimulated several researchers also in Wageningen to come with the DURF program. That's a GMO approach where a cassette is made of 3 or 4 different genes, and that is put into a plant, and that has been proven to be very durable. But that's a GMO. We can do exactly the same. So combine these 3, 4 genes. And we have now a European project that we will demonstrate in 2 years to introduce 2 genes, but we can introduce 4 genes in 4 years.
We're just talking about disease right now, but you could also change other things about the potato, make it bigger, more tasty, perhaps have a more easy shape for industry, perhaps have higher, have more potatoes on one field. You could do a lot of things, I suppose, with this.
Yeah, basically the technology is very generic. It means it doesn't matter which trait you're addressing. You can use this technology for all these different traits. I can give you an example of what you see as soon as in history, many crops are bred by hybrids: tomato, cucumber, eggplant, but also corn, sunflower. So most of the important crops, they have introduced this technology already before. As soon as you introduce this technology into a crop, you see a tremendous impact on the yield For instance, in corn, the hybrid technology has been introduced 100 years ago, and since then the yield has gone up 5 to 6 times. It's not only genetics, but let's say half of genetics. And even more recent, in sugar beet, diploid hybrids were introduced 15 years ago, and since then the yield has increased with 60%. And yield increase means that with the limited resources, you have a much more effective production system. And that has also motivated me very much because, well, it's the third, fourth crop of the world, potato. Well, we all know that in 30 years, will we have 2 to 3 billion more people. How to feed them with the limited sweet water resources, with limited nutrition, etc. And this is a tremendous innovation which can really contribute to food security in the world.
And it will change the market. Now, nobody works for free. I don't ask that of you to work for free. So you have breeding rights. That is the traditional way in which we do it in Holland, which means that if you innovate a crop, everybody can use it for their research. But if you want to bring it to the market, you have to pay the breeder that made the innovation. Also, there's discussion about patents. Can you introduce patents on crop so that anyone, even using it for research or for just simply selling it or all other means, will always have to pay? There's a huge discussion about this. Suppose, Dirk, someone would come up with a much better potato that would sweep the others off the market because they're cheaper, they're more tasty, they look better. They sweep the others off the market. The others are obliged, if they want to use this innovation, to pay the original breeder. Would you say that this would be a game changer on the market?
Yes, and I would like to put this question in a broader context, because I was talking about control, and the way I used this notion of control was to begin with as a technical sense. Hybrid breeding is a technical procedure which allows you more control over the breeding process. But the interesting thing is that by creating this way of control in technical sense, there are also changing things in the world in a social sense in terms of control. And it's very interesting to look at the history of hybrid breeding. Pim referred already to the first attempts at hybrid breeding 100 years ago. And what we have seen since then is also a change in control over the process of breeding in a social sense. Because it started, of course, with farmers who pick particular crops who they see as very interesting, and to use that as a starting material for further breeding. And at the moment that you have this hybrid breeding, creating these plant lines, etc., you see a move from breeding from the farmland to the greenhouse, and in a later stage to the laboratory at the moment that all those biotechnology comes in terms of knowledge and tools. And why is this important? Because it has everything to do with the question you asked me about intellectual property rights. Because at the moment that the whole process of breeding is much more becoming a laboratory affair, a greenhouse affair and a laboratory affair. And it becomes a profession. It becomes institutionalized in commercial firms who are doing this work.
It becomes high-tech, you could say.
It becomes high-tech. Then intellectual property rights also are becoming more and more important. That's what we have been seen happening. And part of that story is also a concentration of the firms that are doing these kind of work. So we know everybody knows about the Monsantos in this world, huge firms who now have a very strong position in breeding based on patents. And I think that, and this is a very important issue, because if we look at the potato, and up to now the potato did not allow this kind of control because it could not be controlled in a technical sense. So the potato, up to now, has not been very interesting for the Monsantos in this world as a crop to breed.
That's how Solynta got in.
That's, well, now we have Solynta as a startup. But the interesting question is, of course, what will happen now? At the moment that we now have this technical control over breeding on the basis of this hybrid breeding, which has been developed on the basis of particular tricks that Pim has developed and has patented, or you have, do you have the patents already, Pim, or is it still?
In certain countries.
In certain countries, okay. So the question, of course, is now what will happen with the issue of control in a social sense? And that's what our project is about.
Who owns the potato? Who gets to make
Yes,
the innovations of the potato?
Who owns the potato? Yes, that's basically the question that it's about. Yes.
Now you could say quite easily, you had a ferry and someone built a bridge. Things happen. That's innovation. That's life. But what would be your response in the case of the potato?
Well, perhaps we can ask Pim.
Yeah, you mentioned several dilemmas. I mean, for me, whether I like patents or not is not an issue. For us, when we started in 2006 with a new technology, we knew the investments are 10, 20, 30 million. The only way to get return on investment, we are not a charity organization, we're a commercial company, is by protecting your innovation by a patent.
And you can't do that by breeding rights. You have to have a patent.
Well, as soon as you have an adult system, mature system, like many other crops of hybrid breeding, you can protect it by breeding rights, because nobody has to get a return of the development of technology because the technology is there. But in this situation, we are developing new technology, and it's very, very expensive. And on top of that, we are developing new varieties. Okay, you can protect your varieties with breeding rights, but you can't protect your technology by breeding rights.
So if someone else would make a change, and then the breeding rights would no longer be sufficient, and you would still not have the payback of your investment.
Right. Yes. Yeah. And for really, also for me personally, it's a dilemma, because we need the money. Without the money, we can't do it. And in our capitalistic system, it means that there are, well, institutes, companies who have the money. And that's also, I mean, we are not, we don't have now enough money to go to the market and have a commercial company. We still are an R&D company. We don't have sales organization. We don't have a production organization. So that's for us also very challenging. And that's also why I like to be involved in this project. On one side, we have our commercial issue. In order to survive, well, we need return on investment. But at the other hand, what are the ways in getting return on investment? Are the Monsantos, Syngentas, the pioneers, are they the only companies who can pay it? Are we then sold by them again?
And so you're here because you're very interested in the social effects, as Dirk said, of the innovation.
Yeah, for instance now, so last year we have been awarded as nice national icon, and Sharon Dijksma, the Minister of Agriculture, is supporting us. And one of the things we are very enthusiastic to perform is to also breeding for developing countries. That is not a commercial activity, so we can't do it alone. But with the help of other organizations, we may do that. So that's exactly what I like. I mean, exactly from a commercial point of view, we shouldn't do it. I mean, there's no value in it. But from a societal point of view, I think it's very important to do it. I mean, we are talking about the third crop in the world, and there are billions of people dependent upon potato for their daily life.
Could it be, you're still about to research this, so you don't have the answer maybe, but there's also a possibility that it will be a wise investment to pay for the patent and still have a better potato, and just to accept that it's someone else's intellectual property, that it can still be a wise decision that is better for everybody. The breeder gets his money, and the farmer gets to make better potatoes, and the customer gets the better. Everybody's happy.
Well, the interesting point of this issue of patents is that you can talk about it in terms of intellectual property. So it's mine, but basically a patent, and now I come again to this point of control, allows you control over the way that you will be dealing with your invention. And one of the opportunities in using that control is also allowing others to work with it. Because you own the patent, there are various possibilities in the way you would like to deal with it. And you can also use the patent as a basis for creating more participatory or collaborative relationship with others in working on this invention. And this is exactly what we would like to think about, and not only think about in an isolated sense, because we also will do that in a participatory way. So we will work with the sector, and we will work with civil society organizations and with policymakers in thinking about this question, how you could deal with these issues in various ways. And we will do that in terms of different scenarios that we will develop and see how you could create conditions for one or different scenarios that you see as particularly desirable in this respect. And desirability, you could say, is you could define in terms of indeed how would you like to use this invention for creating new crops that may serve a variety of communities and needs in the world.
Yeah, I'd really like to add to that. Often I see that people make the mistake, patent means you have a monopoly or a certain invention. It doesn't mean you have a monopoly in the market. Look at the vegetable breeding industry. Most companies are also housed in the Netherlands. They all, just like Monsanto. Monsanto is not unique. Also Rijkswaan and Enza, all the other companies, basically have even more patents in the vegetable sector than Monsanto. But that doesn't give them the monopoly in the market. It is just a way to protecting their intellectual property.
But it does give a monopoly on the breeding, so nobody else can work with it.
No, in this situation, especially for the vegetable industry, they have organized, they call this an international licensing platform. They've said, well, we are all joining 11 companies in this platform, and by doing that, we give each other the license to use these technologies. So just what Dirk said is a way of exchanging, the intellectual property you have. So, and it's also, well, I told you, we are a 100% R&D company, so we need to cooperate with others for the commercialization.
You don't find your way to the market if no one else works with you.
Of course.
Yes.
So we have also to exchange something, and one of our strengths is our technology, which is patented, and makes us a very interesting partner for other, say, participants in the potato sector.
There is another element which I would like to add, which, in my view, also makes this development very exciting to think about, namely that with the introduction of hybrid breeding for the potato, there is also another change, namely the potato as we know it can only be propagated vegetatively by using tubers. And in the Netherlands is the number one producer of potato tubers, which are exported all over the world. And in that sense, the Netherlands has also a very important position in potato breeding. This hybrid breeding allows you to do the breeding by seed. So you don't need the tubers. In the long run, but you can imagine that might have very disruptive effects for the current Dutch potato sector, which is a tuber sector, in that sense, you can also expect it. And I say this because on the one hand, you need the sector. On the other hand, the sector you can expect that the sector will be a bit ambivalent about this whole development, because they see that their current business may completely break down, and they will have to reposition themselves also towards this new technique, how it might be used and further developed.
Thank you very much,
Okay.
and good luck with the research.
Yeah.
Thank you.
Yeah.